Hi there, and welcome to this GCSE Physics revision video on electricity topic of electric charge, static electricity, essentially. So, first of all, we'll have a bit of a recap about what an electrical conductor and insulator are. Okay, so a conductor is a material which allows electrical current to flow easily through it. So examples would be metals. All metals are conductors. Electrical insulators have a very high resistance to the flow of electric current, things like plastics, that kind of thing. So looking through this bit of revision here, so rubber, that's an insulator. Steel, it was a metal, so it's a conductor. Mercury, a liquid metal at room temperature and pressure, but still a conductor. Paper would be an insulator. Plastic also. Now, diamond and graphite, both made of carbon, but diamond is an insulator and graphite is a conductor. So graphite's the kind of thing that's in a mechanical pencil, for instance, okay? So that's a conductor. So the only one you need to maybe remember that isn't a metal for being a conductor would be graphite. So electrical charges then can either be negative or positive. And the negative charges, we think at GCSE, the model we have is of electrons whizzing around the outside of the atom, and they're negatively charged. And then we've got protons that are positively charged together with neutrons, which are neutral, that don't have a charge. Okay, so the positive charge is due to the protons, and a neutral atom would have the same number of electrons as protons. Okay, so it'll be uncharged. So in this case here, we've got 3 protons in the nucleus, and then we've got 3 electrons on the outside there, cancelling each other out. Now, static and current electricity, let's have a look at the difference between those. Static electricity describes a situation where electric charges remain pretty stationary, and this occurs a lot with insulators. Electric current occurs with, and that's another sort of video really about electric current flowing, or another couple of videos, but that occurs when electric charges are moving, or electrons moving from one place to another, flowing. So that occurs with conductors. So the rest of this video is going to be about static electricity. So you can charge materials up using friction. Hopefully you remember doing this in class. So when certain insulate materials are rubbed against each other, they become electrically charged. Now it's really important this, but I'm going to put the full slide up. It's the electrons that are removed from one material to another. The protons, the positive charges, don't move. It's only the negatively charged electrons that move, okay? So never talk about the positive charges moving, because you might lose marks, or at least you won't gain the marks you could have had. So the material, if a material gains electrons, for 2 materials, for example, were neutral beforehand, the material that gains electrons through this friction or rubbing would then become negatively charged overall, because it had an equal number of positive and negative charges before, and through the friction it has gained some electrons, so overall it'll be negatively charged. The material that loses the electrons is left with a positive charge then, similar kind of thing. Okay, so it's lost the electrons, so overall it's got more positive charges than negative charges. It is important to remember, as I said, that the positive charges don't go between the materials. Okay, one thing that's a bit limited in all the models really that you see is that it kind of can get the impression that the one material has lost all of its electrons, which won't be the case. Okay, it'll just be a net transfer of some electrons from one material to the other. Okay, so the example here we've got, now in the old days you used to have to remember perspex and that it would lose electrons and stuff like that, but nowadays generally you don't have to know it for most courses. But polythene would be the other rod then that would maybe gain electrons if it was rubbed by a cloth, for example. So the rod becomes positive here from losing electrons to the dry cloth there. Again, the dry cloth becomes negative. Okay. Now this is a bit extra really, but to see how you can maximize this effect, you could look a bit of extension at the triboelectric series. So the triboelectric series is a big ranking there. You've got things like human hands and asbestos and things like that, and fur. They will acquire a positive charge when rubbed, especially if you rub something from the top with something near the bottom, then you get a big transfer of charge. Okay, stuff near the bottom tends to acquire a negative charge. Okay, things like silicon, Teflon, and lots of plastics there. Okay, but anyway, that's an extra really. Okay, but you could pause the video and have a read of that if you want to. Now, in terms of force on a charge, okay, you might have seen these demonstrations where a column of water might be interrupted or bent by something charged like a rod or a comb. Okay, or you might have charged a balloon and attracted to a wall, for example. Okay, when a charged object's brought close to an uncharged object, so in this case the wall or the water, then the two objects attract each other. Okay, there's a really good video, actually, effect video showing this. So if you search PHET and static, there's a really good, it's not a video, it's more of an animation simulation, which is really good at nailing the understanding of what's going on here, particularly when you've got a neutral object. Okay, so I highly recommend that you search out the PHET static simulation. And it's all about attraction and repulsion in lots of the questions. Okay, so two bodies that carry different types of charge attract each other, and two bodies that carry the same type of charge repel. So the law is, and I'm sure you know this already, like charges repel, unlike charges or opposite charges attract. Okay, now this boy's here, he's just been using a Van de Graaff generator there. I think the boys here has all got the same type of charge, and so they're trying to repel each other, and that causes that effect then. Okay, now this is the classic kind of situation that you might need to sort of set up in an exam question. Sometimes they ask you, how can you tell what charge is on a rod, for instance. Okay, so you could suspend a rod from a piece of string there, so it's hanging freely, and then you can bring another type of charged rod close to it and of a known charge, and then you could figure out what's going on there. Okay, so a charged rod suspended there, like charges repel each other, unlike charges attract each other. So that would be a way of answering some exam questions. You can also, instead of doing it on suspending it like that, you could put it on an upturned watch glass as well. Same kind of thing. Now the hazards, the main word you want to use when we talk about hazards of static electricity is the word spark. Okay, you could have a spark caused, and that could lead to a fire or an explosion. And you got an example there from 2005. The Buncefield oil depot explosion was thought to have been caused by a spark, for example. Okay, so try and use that word spark, and then maybe lead into a fire or an explosion. Okay. So an example could be fuel pipes, could have problems there, but generally, you know, safety is a paramount concern, and we use earthing. Okay, so when oil or petrol is pumped along pipes, a static charge can build up on the pipe, which could result in a spark, which would be pretty catastrophic, given that lots of oil is flammable. Okay, this could cause an explosion when the fuel vapor reacts with the oxygen in the air. So we connect an earth wire. So the earth wire just allows any charge that could build up to flow to Earth safely away. Okay, so it provides a path for the electrons to flow, essentially. Okay, anti-static floors are something that features in things like operating theatres. It's important that you don't get charged up, the surgeons or the anaesthetist. Okay, because you don't want any sparks, and you don't want the anaesthetic gases, which are often flammable, to ignite. Okay. Also, a typical example that comes up in some of the older past paper questions about paint spraying. So a spray nozzle there, you could be painting a bike or something like that. I've seen in some of these videos. A spray nozzle is connected to the positive terminal of an electrostatic generator. As the paint droplets come out of the nozzle there, they repel each other, so they spread out, which is good. Also then, the thing you're painting, if it's metallic, if you connect that to a negative terminal, then hopefully most of the paint then will attract to the panel or the bike or whatever it is you're painting. Okay, and it will go around the back as well, so you'll have to do a good job doing that. Other examples, which you don't have to know in too much detail, but just need to know really that they utilize static electricity to work, are inkjet printers. You can see a sort of diagram there about what's happening. Oops, have a little read of that if you want to pause the slide, but I'm not going to go into that in too much detail. And also photocopiers. Okay, so if you want to read that little bit, have a pause. And I think there's another slide as well. Oops, there we go. But as I said, most exam boards you don't have to know in massive detail how it works, but it is interesting nonetheless. One that does come up and you do have to describe quite often in my experience would be the smoke precipitator or electrostatic precipitator. So chimneys in power stations and factories, they might have this kind of device to try and reduce polluting gases, okay, and dust and things like that. So how do these work then? It's used to prevent dust and ash from entering the atmosphere. So they become charged as they pass through a charged grid of wires. Now sometimes that could be between those two plates, or it could be down the bottom there, sort of at 90 degrees. I've seen it underneath, the whole system there. So a charged grid, and so it becomes charged, and the ash and the dust is then attracted to oppositely charged metal plates. Okay, when the plates are shaken, the accumulated ash and dust falls down to be collected, or you could just remove the plates completely, like a filter, that kind of thing. Okay, and that's how that works. So an electrostatic precipitator is one that I wanted to go into a little bit more detail of. Okay, and that's it. That's a quick whistle-stop tour of revising static electricity. So the main points really there are that it's only the electrons and negative charges that move. Okay, try not to talk about positive charges moving, okay, because they don't. Okay, and some of the uses and dangers really of static electricity. Well, I hope you enjoyed that video. If you did, please like and subscribe, and watch some of the other videos that I've uploaded on GCSE Physics. Thank you.